Hello, welcome to CM Square, and this is John Choi, the founder of CM Square and also the IB Mathematics tutor. As you all know, the IB Math has already changed to a new syllabus, AA or AI. And the first teaching has already started at this year, September, and the first examination will be in May 2021. So I hope you guys can prepare well for the real exam because you still have more than 1.5 years to prepare it. And in this video, I will introduce the IB Math AASL, which is Analysis and Approaches. And in the examination, you have to do two papers. Paper 1 is long calculator, and paper 2 is a calculator questions. So please make sure you know how to use your GDC to do a paper 2. And there are 5 topics in IB Math AASL, one less topic than the IB Math SL. Because IB organization has already eliminated the factor this topic, so which is no longer in Math SL this syllabus. And IB Math AASL is very similar to the old Math SL syllabus, very similar. So let's take a look at the notes for each topic. So topic 1 is number and algebra, and in our center we have total 8 notes for this topic. The first 2 is for a arithmetic and geometric sequence. And these 2 notes covering the concept of finding the nth term or the sum of nth term of each sequence. And the formula is also given on the formula booklet here. So you see UN and SM for both arithmetic and geometric sequence. But one extra formula for a geometric sequence is to find the sum of infinite geometric sequence. And you have to check the limitation. Like the common ratio, the absolute value for the common ratio is more than 1. So please check it carefully. And note 3 is to cover the concept of sigma notation, which is so sigma means sum. You have to expand the sigma notation like finding the sum of the sequence. It can be arithmetic or geometric. And note 4 I would say is the application for geometric sequence, which cover the concept of compound interest or sometimes simple interest. And the formula for compound interest is given on the formula book here. And it also covers the concept of depreciation. So again, it's a GCSE questions, so please make sure you can use the formula in the GCSE to calculate the compound interest. So note 5 and note 6 is exponent and logarithm. Note 5 covering the concept of law of exponent. Let's say x power a times x power b equals x power a times a plus b, like this. Or x power a to the power b equals x power ab. All these law of exponent. Note 6 is logarithm. We cover the law of logarithm here. And also all the formula is given on the formula book. There are 4 formulas. But we also cover the exam technique or some special skill for logarithm. Note 7 and Note 8 is for binomial expansion. So Note 7, binomial expansion will cover the formula. It's also given in the formula book here. So how do you expand the binomial functions? And I will have one hint to you guys is that this term is called the nth term, or I can say the TR plus 1 term, which is very useful in the IB exam because you can use it to find the coefficient of let's say x power n, or you can find the nth term directly, right? So yeah, please make sure you know how to use this term. And the second formula in this topic is NCR. That's in paper 1, long calculator question. You can calculate the NCR without calculator using this formula. And note 8 will cover all the hard question or all the level 7 questions for binomial expansion in our notes. So topic 2, functions. So there are total 7 notes in our center for topic 7. Topic 2, functions. The first note is a straight line. So let's say calculate the slope of a straight line using the formula on the formula book. So it's rise over run. Also finding the equation of a straight line. The slope-intercept form, the m is the gradient and the c is the y-intercept, right? And this one is called a general form of a straight line. So also 2 parallel straight lines, that means the gradients are equal. And the 2 perpendicular straight lines, that means the gradient is negative reciprocal. or m1 times m2 equals -1. Note 2 will cover the axis of symmetry and also completing the square. So axis of symmetry is the vertical straight line that pass through the vertex of a quadratic functions. Also split the graph into two symmetric parts, two separate parts. Okay? So it's a vertical straight line. The equation is always x equal a constant. Let's say x equals 1, x equals 2. Don't just write 1, you have to write x equals 1. It's an equation, so be careful here. And also finding the axis of symmetry, you can use a formula x equals -b/2a when you know the general form of the quadratic functions. And completing the square is to convert the ax squared plus bx plus c this form into vertex form, which you can find the vertex, the coordinate, both x and y of the vertex directly. So the form is like ax minus h squared plus k, where h and k are the x and y coordinate for the vertex. But not only for this form, we also cover the root form, x minus p, x minus q, so like this, where p and q are the roots of the functions. And note 3 is for composite and inverse function. So composite function is like f dot gx, all these. And inverse function is the f with power, let's say, like f -1x, right? So you should know how the inverse function is formed from the original functions. The xy swap. And yeah, also the asymptote also swap. Let's say the horizontal asymptote become a vertical asymptote. Note 4 is discriminant. So discriminant is a delta here, is a b squared minus 4ac. Delta is the square root inside of a quadratic equations. So we can calculate the sign of a delta. So let's say delta can be 0, can be positive or negative, which can determine the nature of the quadratic function, whether it touch one point on the x-axis, or it doesn't touch the x-axis, or it touches two different points. So you can determine the nature of the functions. Note 5 will be the asymptote, let's say the horizontal or vertical asymptote, especially for a reciprocal function or rational functions. For domain range, why would I put these two concepts into one note? Because for finding the domain range of a function, you need to find the asymptote first. So domain means the x value, and range means the y values. So note 6, transforming functions. So all the vertical, horizontal translation, and also vertical and horizontal stretching. So AD will affect the y value, so affect the vertical. A is vertical stretching, and D is the vertical translation. B and C affect the x values, right? And B will affect the horizontal stretching, and C will also affect the horizontal translation, shift left or shift right, all these concepts. And the last note, note 7, will cover the concept of graph of exponent and logarithm. So like using your GDC to plot the graph of an exponent or a log graph. Yeah. So for plotting the graph, no matter a function like quadratic function or straight line, so all you need to find is to find the intercept, y-intercept, or the root, or sometimes the vertex. Also the HA, horizontal or vertical asymptote. All these are the key things you need to find for plotting the graph. And topic 3 is geometry and trigonometry. So in this topic, we have total 8 notes. The first one is a trigonometric function transformation, which is very similar to the function transformation, but applied to sine and cosine graph. So sine graph and cosine graph, U-shape, and as a wave function for sine graph. And note 2 is a unit circle. So using all the formula in data book, in the formula book here, let's say the identity of a tangent, Pythagorean identity, and also double angle identity. The third one is a Ferris wheel. Ferris wheel is the application part of the function transformation. But not only Ferris wheel, but also some real-life example, real-life situation. And note 4, 5, and 6 is for setter and triangle. So setter, there are two formulas in setter. Finding the arc length and finding the area of setter using these two formulas. But when you use these two formulas, the angle of setter must be in radian. So please check carefully. For triangle, there are several formulas like sine rule, cosine rule, and also the area of triangle, the area of long right angle triangle. Because for right angle triangle is easy, so base times height over 2 is the area for the right angle triangle. But this is a formula for a long right angle triangle. So there are 3 notes because we have a paper 2 questions and also all the level 7 questions, all the hard questions in the note 6 here. And note 7 is a bearing or angle of elevation and depression. That's new to the IBMYP AA as a syllabus. And note 8 is 3D shape. So let's say finding the volume of a pyramid, the cone, or the area, surface area for the cone, or even a sphere. So I would suggest you to do the math study past paper as a practice. Math study past paper. You can find all these questions, the past paper question. So topic 4 is a statistic and probability. We have total 8 notes in this topic, and the first 2 topics is for statistic. The first one, statistic, cover the mean, the median, mean, mode, and median. So finding these 3 things for a set of data. Also Q1 or Q3, or also the IQR. So using GCSE. So please make sure you know how to use your calculator to find it. Also the box and physical diagram, and also the cumulative frequency graph. The second one, also a GCSE. Or I can say this topic is all GCSE. Finding the correlation coefficient, so whether the 2 events are positive or negative correlated, or let's say find the equation of a best fit line. So all these concepts. The third one is a Venn diagram. So Venn diagram, you will see some formula in the formula book here. Yeah, here. Let's say the 2 circles doesn't overlap, like mutually exclusive, independent event, all these. Or sometimes complementary event, let's say A. So inside circle A is a probability of A, but outside circle A is A prime. Yeah, all these concepts for Venn diagram. And note 4 is law of probability. So all these law of probability is given on the formula board. The combined event, the mutually exclusive, as I mentioned before, the 2 circles do not overlap, or the conditional probability. So students always confused with this formula, the conditional probability. Also independent event, that means the 2 events, they won't affect each other. Let's say throwing a coin and also throwing a dice. So getting a head of a coin is 1/2, but getting a number 1 face down of a dice is 1/6. They won't affect each other. So that's called independent event. Question 5, probability. So probability, the formula is a number of event A over number of total. So using this formula. But of course, there are some hard questions you will see in our notes. And note 7 is probability distribution. Like the question will give you a distribution table, like event A, like 1, 2, 3. These are all the possibility, and that's a probability for each event. And the key thing is that sum of the probability equals 1. And the further, maybe the external part is to find the expected value in this table. Note 7 and Note 8. Note 7 is for binomial distribution, so using GDC to find it. N is the number of total, and P is the successful probability, right? So the failure probability would be, I would say Q. Q is equals 1 minus P. And last one, normal distribution. its normal distribution is a graph like this, symmetric curve. So all mean, mode, median is in the middle. Mean, mode, median is all in the middle, from negative infinity to positive infinity. And that's the formula for calculating the standardized normal variable. So Z equals X minus mean over SD. So using your GCSE, either CDF or invert normal. Yeah. And the last topic will be topic 5, calculus. And in this topic, there are two separate parts. Part A is a differentiation, and part B is an anti-differentiation, or can say integration. We have total 9 notes in total for this topic. Very similar to the old IBMYP SL syllabus. The first note is limits. So limits, let's say calculating the value approaching, let's say 0 or approaching a particular value. Note 2 will cover all the differentiation rules. So even all the differentiation rule is given on the formula book here, but some are very tedious. Let's say the product rule, quotient rule. So product rule is for multiply, quotient rule is for fraction. And all the simple derivative, right? You put the power down and then power subtract 1 here. Also the derivative for a trig function sine and cosine, but it only shows the way to derivative the simple function. Let's say cosine x and sine x. But what if the function is a composite function, let's say sine 2x or sine 2x squared? So how to differentiate? We can use a chain rule here. But I won't follow this formula here for using the chain rule. I will have another skill which is easier. We will also cover it in the note 2 here, the differentiation rules. Also exponent and lateral law. So for composite function, let's say e power 2x or lateral law like x squared. We'll cover all these questions in the note 2. The third one is to find the equation of a tangent or normal line. So tangent and normal are perpendicular to each other. That means the slope are negative reciprocal. Note 4 is increasing, decreasing function and turning point. Turning point may be the maximum point or minimum point. We can use a second derivative to determine whether it's a max or mean, or sometimes the point of inflection. So POI, the point of inflection, where the second derivative equals 0. So increasing and decreasing function means the curve is going up or going down. Going up means the slope is positive, and going down means the slope is negative here. And one more thing, for the test, let's say maximum or minimum point, the slope always equals 0. So these are the key things. And the last note for differentiation is a kinematic. So displacement to velocity to acceleration. So all these concepts. And part B, integration. So of course the first one will cover all the integration rules, like here. And then note 2 will cover the concept of integration by substitution for product and quotient rule. I mean, we don't have integration in product. We don't have product rule and quotient rule in integration, but when we are integrating a function like 2 times the multiply or a fraction, we can use the skill of integration by substitutions. And note 3 is finding the area below the curve, like using the definite integral. Also, you can use your GCSE to calculate it in paper 2. And last one is a integration kinematic. So it's a reverse process, acceleration to velocity to displacement. So that's all the notes in our center and for IBMYP AASL syllabus. So if you guys want to know more about the course content, you can leave a comment below, and also we'll add the link for Facebook, IG, and our WhatsApp. So you can follow our Facebook and also our Instagram, because we will keep posting the video for the past paper solution for math and also other subjects. Thank you.